Welcome to topic number 22 in Richard James Mathematics Resources. This topic is entitled The Equation of a Straight Line. The equation of a straight line is such an important tool in mathematics and its related subjects that it is one of the most popular of devices. It is very flexible and has a wide range of applications. Some expressions and equations are approximated to the equation of a straight line, and others are written in its form in order to increase their usefulness and comprehensibility. Correlation and regression, the action of a simple pendulum, direct and inverse variations, the cosine rule, Hooke's law, linear programming, and all relationships that involve some degree of proportionality require the application of equation of a straight line. The general form of the equation of a straight line is y is equal to mx plus c. For any graph on a rectangular coordinate system, reference must be made to both x and y axes. A straight line is also a graph. Any point on a line must have an x-ordinate and a y-ordinate. Now we have this point that we have right here on the line. The x-ordinate is its position relative to the x-axis, as we can see, and its y-ordinate is the position relative to the y-axis. The x and y in the equation are general positions relative to the axes and also help to define the relationship between the x and the y ordinates of any point on the line. C is the y-intercept, the point where the line crosses the y-axis. At this point, the x-ordinate is equal to 0. There's our point C. This is where it crosses the y-axis. So C, y is equal to mx plus c. So this c that we have in the equation is the y-intercept where the line crosses the y-axis. Of course, if we should draw a line like this to check on its position relative to the x-axis, we'll realize that the x-ordinate at this point is equal to 0. M is the gradient or slope of the line and also helps to define the relationship between the x and y ordinates of any point on the line. The features of the gradient will be discussed later. A general problem in this topic is to take the equation of a straight line and write it in the general form. An additional requirement is to determine the values of m and c. So we may take any equation that we see. It might be a little bit weird, might not be so sophisticated, and we are required to write it in the form y is equal to mx plus c. Then we should be able, because we should have it right in front of us blatantly, and be able to determine the values of m and c. So there we have 4 equations. They are equations of straight lines, and we are going to write each one in the general form y is equal to mx plus c. Then we are going to determine the values of m and c. What is the value of c? The y-intercept. And the value of m? The gradient or slope. The equations on the right will be written in the general form. This requires transposition. So there's our first one. Y plus 5x is equal to 7. So what do? We know that we need to have y on the left-hand side alone. Therefore, the 5x needs to go to the other side. So let's do that. And of course, by transposition, it is going to acquire by transposition a negative sign on the right-hand side. So there we have it. Y is equal to 7 minus 5x. However, this does not match with the equation of a straight line as it is given in the general form. See, the general form requires that we have mx plus c. Therefore, the term in x is placed at the front. It's not a must, but it is in line with the form. You go to the passport office and you get a form. You do not copy the questions of the form and write the answers as you please. You're going to write the answers in the form in exactly how it is required. And that is what we are doing here with our equations of a straight line. If we wish to maintain the general form as required, the negative 5x should be placed before the 7. Like that. And now we have our general form. Now, we have a negative in front. Generally, we don't delight in putting negative signs at the front of an expression, but in this case, we are really maintaining the form, and that is why it is done. Our second equation, 3x minus 4y is equal to 9. Well, one good approach might be to put the negative 4y to the other side where it becomes a positive 4y. Let's see if that is what we will do in the long run. For now, 4y is transposed to the right. Y should be the subject and be given a positive value. That will help our plight. So let us see what we do. Yes, so the 4y is placed on the right. And of course, the 9 that we have here is placed on the left. It is a positive 9, not accompanied by any sign, transposed to the other side where it becomes a negative 9. So let us turn the equation around. If we have here 3x minus 9 is equal to 4y, then 4y must be equal to 3x minus 9, and that is what we have there. So our further transposition is like this. Say we have 4y here, 4 multiplied by y, we divide by 4 on the other side. However, if we take a look at it, it is not going to be in the same form. The form requires that we have something multiplied by x or some term in x and then a pure number. So in order to do that, we divide each term by 4. Do not forget that when we have an equation or an expression with a denominator like we have right there, we cannot just divide the 3 by the 4 and leave the 9 alone, or divide the 9 by the 4 and leave the 3 alone. We'll have to divide each term in the numerator by the denominator. And that is what we have done, and the result is right there. We have another one. 2y minus 4x minus 8 is equal to 0. Of course, the negative 4y, the negative 8 will be transposed to the other side. Those will acquire positive signs, and no problem right there. Now we have 2y. What do we say if we have 2y? 2 multiplied by y, we divide by 2 on the other side. So each term is to be divided by 2. So we have 4 divided by 2 and we have 8 divided by 2. And this is why we have our 2x plus 4y right there. Finally, 7y plus x is equal to 14. So what do we do first? Get rid of that x that we have positive on the left-hand side. So we are going to have that x positive on the left-hand side. We transpose it to a negative x. As usual, the term in x is placed at the front in order to maintain the form. Then we are going to divide by the 7. So we have 7y here, so we need to divide by 7, and each term has to be divided by 7, and that is our answer. Of course, 14 divided by 7 is 2, so we don't really need to write that as a fraction. The right-hand side of the last equation could have been written as a single fraction, but that would have been out of line with the required form. The required form has 2 distinct terms, and we need to maintain the appearance. So, we are going to take a look at the equations. The first one is y is equal to negative 5x plus 7. So those equations that we have right there we are going to write the gradient and the y-intercept of each one of them. So we are looking at the first case. The gradient is the coefficient of x. So this is the gradient, the coefficient of x. And what is the coefficient of x? The gradient is equal to -5. M is equal to -5. The constant is the value of c. So c is right here, a +7. So c is equal to a +7. The gradient is -5 and the y-intercept is 7. That is your other one. What is the coefficient of x? The gradient is the coefficient of x, and that is 3/4. So the gradient m is 3/4. The y-intercept is the value of c as usual. So c is equal to -9/4. That is the pure number that we have right there. That is your y-intercept. The gradient is the number accompanying the x as usual, which is the x coefficient, that is the gradient. So m is equal to 2. The pure number is the value of c. So c is right there. C is equal to 4. Finally, as usual, the invisible numerator is 1 and the gradient is given by, no, this is what we have, just -x/7. So what number would be accompanying the x right here? Typically, we'll have 1. So that gradient is -1/7. The pure number, of course, at the end is the value of the constant, which is the y-intercept, and there we have it. Now we're going to be taking a look at the gradient. The gradient of the line is a single number that tells us how y changes with x as we traverse the line. It tells us whether y changes to a greater or lesser degree than x, or whether y increases or decreases as x increases. So it gives us a general idea of how y changes with respect to x. So let us consider two general points on the line. So that's what we are looking at the gradient. Good. We have our points P and Q. Good. The points may be given general coordinates. So let us give our general coordinates. One is x2, y2. One is x1, y1. So we have x1, y1, x2, y2. That's general. So let us see how the coordinates relate to the axis. Remember that these coordinates will give us positions relative to the x and y axes. There we have them. So we have here y2 is the value that this, if we should go straight across, this point would be y2 on this axis. And of course x2 will be this point here, where it crosses this axis. But of course we are just using dotted lines in order to get an idea of what these really mean. So it means that if we go in this direction by x2 and then we move up by y2, then we would have located this point. And the same thing applies right here. So y1 is the position right here on the axis, and x1 is the position right there on the axis. The gradient requires an examination of how y changes with x. Let us therefore look at the difference between the x ordinates and the difference between the y ordinates. So we are going to put in the difference. So the difference between these two is y2 minus y1. And the difference here is x2 minus x1. This ratio is given by m is equal to y2 minus y1 over x2 minus x1. Right? And this is why we have done it. The gradient of a line can be determined by finding the ratio of the y movement to the x movement. So it's the ratio of the y movement to the x movement. So the x movement, or the y, let's look at the y movement. The y movement is from here to here, which is y2 minus y1, and the x movement is from here to here, which is x2 minus x1. So the ratio of the y movement to the x movement tells us the gradient. It may also be given by y1 minus y2 over x1 minus x2. The second expression, when compared with the first, means that only signs will be changed. If the signs of both numerator and denominator change, the expression will remain the same. The formula that is used to determine the length of a segment of a line is an extension of the Pythagoras theorem. We are going to be looking in this section at the length of a segment. That is, if we have a portion of a line that is marked by 2 points, we can find the length associated with that. So we have here, say we have Q here and P here. You need to find the length of the segment from P to Q. So that is what we are doing. And we are using Pythagoras theorem. The length of the segment may be shown on the diagram. So we have that length of the segment. That is the length of the segment shown on the diagram right there. According to Pythagoras, the length of the segment is given by the equation L is equal to what? See, don't forget this. This is your x movement, x2 minus x1, and this is your y movement, y2 minus y1. So this movement, Pythagoras' theorem says that the square of this length, which is going to be the hypotenuse, which will be discussed in detail when we take a look at trigonometry, working with right-angled triangles. So the length of this squared is equal to the square of this plus the square of this. And that is how we derive this. Now, in order to take a good look at this in detail, the topic in trigonometry that comes under right-angled triangles have done this in detail. So we may take a good look at that one in order that the details of this might be understood. Now we're going to be looking at midpoint. And of course, midpoint shouldn't come as any surprise. The midpoint of a segment that joins P and Q can be easily seen if we take the x-ordinate together and the y-ordinates together. Let us take a general thing. The number halfway between 10 and 20 is 15. This can be determined by adding 10 and 20, then dividing the result by 2. So midpoint is also an average. So this is how we are going to do. So all we have to do is take the average of the x-ordinates, take the average of the y-ordinates. That should be no problem. So find the average of the x-ordinates. We have that right there. And take the average of the y-ordinates. So that is what we have right there. So we have y1 plus y2 over 2 and x1 plus x2 over 2. And the position is given right there. The coordinates of the midpoint can therefore be given by the following equation. So the midpoint is the x-ordinate, which is the average of the two x-ordinates, and the y-ordinates, which is the average of the two y-ordinates. Now that we have the formulae of the gradient, the midpoint, and the length of the segment, we are going to use them in order to find length of segment, gradient, and midpoint that are associated with 2 points. So we have 2 points on a line right there. Now, we may just look at them and be able to insert the instruction into the equations. But let's see if we can take a more systematic approach to it. The points can be shown to be associated with the symbols in the formulae. So put the symbols there that are in the formulae. Take the formula for the midpoint. So we're going to be looking at the formula for the midpoint. This is the formula for the midpoint, right? And we have 2 points, and this can be said to be x1, y1, and this can be said to be x2, y2. So x1 is negative 2, y1 is 5, x2 is 1, y2 is 9. Insert the numbers in their respective positions. So we're going to put them in this equation here. So x1 goes there. This x2 from here will go there. Now that we know where the numbers are supposed to be placed in the formulae, let us go straight ahead and do that. So, well, the rest of it is simple arithmetic. We are going to negative 2 plus 1, and that is going to be a negative 1. And also 5 plus 9 is 14, and we're going to divide by 2. So let's do that. So the midpoint turns out to be negative 1/2 and 7. So take the formula for the gradient now. M is equal to y2 minus y1 over x2 minus x1. Insert the numbers in their respective positions. So what we are going to say, this is y2, which is 9, it goes right there. And y1 is 5, it goes there. x2 is 1, goes there. And x1 is negative 2, and it will go right there. So that's all we need to do. And as usual, it's a matter of arithmetic. 9 minus 5 is 4, and 1 minus negative 2. Do not forget these consecutive signs. They are like signs, so we replace them with a positive sign. Let us apply the alternative formula, which is the other one. M is equal to y2 minus y1 this time minus y2 over x1 minus x2. So we are going to do our substitution. All right. What happens here is that we have m is equal to negative 4 to be divided by negative 3. Of course, negative divided by negative is positive. Negative divided by negative gives positive, and the answer is the same as before. So it does not matter whether we say y2 minus y1 or we say y1 minus y2. In the long run, the answer is going to turn out to be the same. Take the formula for the length of the segment. L is equal to x2 minus x1 all squared plus y2 minus y1 all squared. Of course, you know that it does not matter. A lot of stuff here does not matter. 1, it does not matter if we put y2 minus y1 here instead of x2 minus x1. It does not matter. And it does not matter if we say x1 minus x2, because when we square, the answer is going to turn out to be the same. Because if we square a negative quantity, say negative 5, we are going to get the same answer as if we squared a positive 5. There are a lot of stuff that do not matter right here, right now. So we know the values to go here. As a matter of fact, say x2, we know it is 1. x1, we know that is a negative 2, and so on. So there we have it. And all we need to do is simplify this expression. Do not forget 1 minus minus 2. That is going to be a positive 3 because consecutive signs right there. So we're going to have a positive 3 squared. 9 minus 5 is 4 squared. So next step, we square 3, we get 9. We square 4, we get 16. Then we add 9 plus 16, we get 25. The square root of 25 is 5. So that's 5 units. The length of the segment is 5 units. So we're going to do the same thing for a different pair of points. And here we are including our x1, y1, x2, y2 in order that we can have some order in the way that we are going to insert our values into the equations. So that is for the midpoint, and of course we're going to have x1, 8. This one is 3, so 8 plus 3. Then the y's, the 7 goes there, and the negative 5 goes there. And that's all there is to it. So that's how we insert the numbers in their respective positions. Right. Now we need to simplify. Consecutive signs, they are like signs. We're going to replace them with a negative sign. So it will be 7 minus 5, which is 2. And then we divide that by 2, and we'll get 1. 8 plus 3 is 11 to be divided by 2. So we write 11 over 2. Some students may write 5.5, but I'm choosing to go ahead with vulgar fractions or even improper fractions. Take the formula for the gradient, and we do the same thing. y2 is negative 5, it goes there. y1 is 7, it will go right there. And then we do the same thing for the x's, and the numbers will be inserted in the rightful places. It's just a matter of simplification now. Negative 5 minus 7, rule 2 in. So this is negative 5 minus 7, this is rule 2 in directed numbers, adding numbers that have like signs. We have a negative 12 right there. 3 minus 8 is negative 5. That is for rule 1 in directed numbers. Of course, negative divided by negative is positive. So the answer, gradient, is 12 over 5. Length of segment? Right. The one that we need to remember the least things about. So we're going to insert our numbers in the same way. Of course, x2 is 3, x1 is 8. So 3, 8. y2 is negative 5. y1 is 7. So negative 5, 7. And that is what we have right there. So we are going to have 3 minus 8. So that's going to give a negative 5. Negative 5 minus 7, that's a negative 12. Right. So when we square negative 5, we're going to get a positive 25. And when we square negative 12, we are going to get a positive 144. Add these, we get 169. The square root of 169 is 13, and the length of the line is 13 units. Finally, we are going to take this pair, and we are going to find the midpoint first, as usual. So let's find the midpoint. Of course, it's a matter of putting the information there. There is no guide right here this time. So no problem. This is x1 is 4. This is the negative 11 will go there for x2. y1 is 6. y2 is negative 2. So let's see what happens. Good. Then we simplify. Consecutive unlike sign, we replace that with a negative sign. Consecutive unlike sign, we replace that with a negative sign. So we're going to have here 4 minus 11, and we will get a negative 7. So that is negative 7 over 2. This one is 6 minus 2. That's 4 to divide by 2, and we will get 2 right there. Let us move on and determine the gradient of the line. Take the formula for the gradient right there. y2 minus y1 over x2 minus x1. Insert the numbers in their respective positions. Now, what do we have here? Notice that what we have here is actually y2, y1 going first, and the one that we call y2 is going second. So we have x1 goes first again, and x2 goes next. The fact is, it does not matter which point we call x1, y1 or x2, y2. It really does not matter. And of course, we have shown already that it does not matter if we choose to say y2 minus y1 or y1 minus y2 first. Simplifying, we have this. Of course, we have this minus minus consecutive negative signs to be converted to a positive, and we have the same thing right there. Notice that while substituting into the equation, the ordinates of the first point are placed first. There is no harm done because if the formula were written in the reverse, it would have given the correct answer. Any ordinate may be used first as long as consistency is maintained. That is, the point that is used first for the y ordinate should be used first for the x ordinate. Need to determine the length of segment now, and we are going to insert the numbers in their respective positions as usual. When that is done, this is what we would have, and then we can simplify that, and we will get 15 squared plus 8 squared. Square 15 we get 225, square 8 we get 64. Add them together we get 289, and of course the square root of 289 is 17. Now we are going to determine the equation of a straight line. So we need information in order to determine the equation of a straight line. But let's see what we really need. If you choose a straight line from outer space, there's one thing that is going to be true about it. It will have a constant slope. That is, the gradient is always going to be the same, irrespective of the 2 points that you use to calculate it. So any 2 points that you use to calculate the gradient on a line, that value of the gradient is always going to be the same for the straight line. Let us choose a point P of known coordinates. Let us say that point is of known coordinates x1, y1. So let us also bear in mind that an equation is a general expression used to locate any point on the line. Let Q be any point on the line. Its coordinates will be given a general representation also. Right, and that is as general as we can get. Q is a point x, y. Now remember, it is a gradient that is consistent on the line, and then that can also be used to determine the gradient of the line. So the gradient is a constant at all points on the line. This may therefore be used to give a general representation of the line. So what is gradient? We can say y minus y1 over x minus x1. Here we have it again, y minus y1 over x minus x1. That is the gradient that we'll have. The equation may be transposed in order to derive a formula that can be generally used to determine the equation of a straight line. So this m is going to be multiplied by x minus x1, and that is equal to y minus y1, because we have this as a denominator, and if we are going to transpose, we need to get rid of a denominator by multiplying by the entire denominator on the left hand side. So we are going to place the y's on the left hand side, and of course the other terms will go to the left. The general equation y is equal to mx plus c may also be used. Now let us take a look at what we have here. These are the 2 points that are on the line. Do not forget that the gradient is y difference over x difference, and it may be y1 minus y over x1 minus x, and it may be y minus y1 over x minus x1. In the long run, irrespective of how we do it, the transposition can be shown to be the same by just adjusting the signs, not violating any mathematical principles, by the way. In order to determine the equation of a straight line, we need to know 2 things. One point through which the line passes, and the gradient of the line. The equation that may be used are y minus y1 is equal to gradient x minus x1, the one that we have just derived. And of course, y is equal to mx plus c. Apart from the formulae that we have, we may use another method to determine the equation of a straight line, but we'll take a look at that when we get to it. The following are points accompanied by the gradients of the line that passes through each. Determine the equation of a line. So there we have some points here with the coordinates. The coordinates are the ones that are the points, and then we have the gradient of a line that passes through this point, the gradient of the line that passes through this one, and so on. And we are going to determine the equation of each. So we are going to take a look at this one first. The point is 7, -3, and the gradient is -2. So -2, of course, we have it there, the gradient and the coordinates. As usual, the first digit is the x ordinate and the second digit is the y ordinate. Never forget that. The arrows show how the numbers are substituted into the general equation. So we have the point and the gradient. How do we substitute that in our equation? Y is equal to mx plus c. Right, the value of y goes as y. The value of the gradient goes right there. And the value of x goes right there. Now, what about c? Our duty is to determine the value of c. The arrows will again show how the numbers are substituted into the derived equation. So we have another equation, that one. So this is our equation that we have over here. What happens? The value of y1 is this. This is our y ordinate. It is the value of y1. The gradient is right there, the value of m. And the value of x1 is the x ordinate that we have here. So what about these? Y and x? Those are the general representation of the x and y axes. So this is our first one. So we're going to use y minus y1 is equal to gradient x minus x1. So what do? We substitute. So when we substitute, the value of y1 will go right there. So we'll have y minus -5. The gradient is 3, it will go right here. And then we have x minus, what is x1? The x ordinate, x minus -1. Good. So we are going to just simplify and leave our equation in the general form, y is equal to mx plus c. So we're going to simplify. So this is y plus 5 right there, negative, negative, consecutive negative signs, right? And consecutive negative signs right there also. So we have 3 into all of x plus 1. Expand in the brackets, and then we transpose. Now, this positive 5 is going to be on this side as a -5, so we have 3 minus 5, so we're going to have, in the long run, y is equal to 3x minus 2. And we are through with that one. So we are going to also use y is equal to mx plus c to determine the equation of a line. So we substitute. What do we get? So let's go. So y. So y is -5, it goes there. M is a gradient, it is 3, it goes there. X is -1, it goes there. So what about c? So we're going to simplify now that we have substituted. So we have this and transpose. And of course, this is just a very simple equation. Of course, we can solve that. C is it going to be equal to -2. And by using this method, we first have to determine the value of c. So we have a general form of the equation of a line here. Y is equal to mx plus c. So all we need to do is to insert the values of m and c. Now, what is the value of m? The gradient that we started off with, what is that? 3. So m is 3 and c is -2. So y is equal to 3x minus 2, which is the same one that we have right over here. irrespective of the method that we use, the equations will be the same. The general form is y is equal to mx plus c. We already know the value of m that is given. All we need to do is determine the value of c, and that we have done. In the end, 3 takes the place of m, and negative 2 takes the place of c, and that's all there is to it. So here we have another one. The equation of the line is y minus y1 is equal to gradient x minus x1. And of course, this is our x ordinate. And of course, it will take the place of x1 right here. Our y ordinate, negative 3, will go right there. And our gradient m is negative 2. Negative 2 will go right there. Right. So after we have done that, we just simplify. Finish by transposing. So we have y plus 3, and of course this is going to be transposed to the other side where it becomes a negative 3. So 2x plus 14 minus 3, so we have y is equal to 2x plus 11. Now we're going to use y is equal to mx plus c. Y is this value of y, negative 3. M is negative 2, goes right there. X is 7, that will go right there. The only thing that is missing is c, and we put all of those into the equation and simplify in order to determine the value of c. So negative 2 times 7 is negative 14, and then we're going to transpose this negative 14 to the other side where it becomes positive 14. 14 minus 3 is equal to 11, and that is what we'll have for our c. This is our general form. Y is equal to mx plus c. What is m? The gradient that we got at the beginning, negative 2. What is c? C is the 11 that we have just calculated. So y is equal to negative 2 times x plus 11. That's what we have. Y is equal to negative 2 x plus 7. And we have another one right there. So the y part is 6, goes right there. The x part is 4, goes right there. The gradient is 3 over 2, and it will go right there. So let us just substitute and see what we get. And we are going to simplify. In simplification, what will happen? This fraction is going to be multiplied by the x that we have right there. No problem. Now the next one, we are going to multiply this by negative 4, in which event this 2 will cancel with this 4 and leave 2. So when we multiply this by this, remember that each term that's inside the bracket is going to be multiplied by the one number that is in front of the bracket. So if we multiply this by the x, we will have 3x over 2 or 3 over 2x. And then we are going to multiply the 3 over 2 by the negative 4. And what will that give? 2 into 4, 2, 3, 2, 6. So that's going to give us a negative 6 there also. Good. Now we need to transpose this negative 6 to the right-hand side. It becomes a positive 6. And the 6's will be additive inverses, and they will take care of each other. The right-hand side will just have 3 over 2x. And we are through. Y is equal to mx plus c. Y is 6. M is 3 over 2. M is 3 over 2. And x is 4. We do not know c, so we are going to try to determine c. Good. So we say 2 into 4 is 2 times 3 is 6. So we'll have 6 is equal to 6 plus c. When this is transposed to the other side, we'll have 6 minus 6, which is equal to 0. So c is equal to 0. So y is equal to mx plus c. Y is equal to m. M is 3 over 2 times x. C is 0. If we add 0 to this, it is going to be the same thing. So we don't need to have a positive 0 right there. Now, given 2 points through which a line passes, determine the equation of a line in each case. We have the 2 points, and what do we need to know in order to determine the equation of a straight line? To determine the equation of a line, we need its gradient and a point through which it passes. We do not have the gradient. we may use the points to find it and use it with one of the points to determine the equation of the straight line. Take the formula for the gradient. So we need to find the gradient. So let us find the gradient. And of course, we have done that so many times that at this stage, we do not have to go through the so-called nitty-gritty in order to determine the gradient. Insert the numbers in their respective positions. Good. And then when we simplify this, we get m is equal to negative 9 over 3. So that is going to be negative 9 to be divided by 3. That is equal to negative 3. And that is our gradient. The answer will be the same irrespective of the point that we use to accompany the gradient. However, if one point is simpler, use it. Simpler may mean smaller or smaller number of negative signs. So if we have a fewer number of negative signs, we may use that. Or if the ordinates, the numerical values of the ordinates are smaller, we may use them also. So we're going to use a simpler one. Remember now that we need to use the gradient accompanied by the point in order to determine the equation of a line. So we are going to use y is equal to mx plus c in this particular case. And of course, we are going to substitute like we did just before. Good. And we simplify and we find the value of c. So the value of c in that case is 0. So y is equal to negative 3x. Now remember, y is equal to mx plus c. M is negative 3 and c is 0. So y is equal to negative 3x plus 0. But we do not need to include the 0 right there. Now, we are going to continue and we are going to use two other points. We are going to determine the gradient, of course. Insert the numbers in their respective positions. And just like the substitution that we have done before. And then, after we have done that, we are going to simplify. And the gradient is negative 2. One can hardly find a reason to say that 6-2 is simpler, but let's pick it. So 6-2 might not be simpler than 5-4. Maybe just touch and go, so we choose any point. Any point that we choose will give the answer nonetheless. So we're going to use, this time, we use y is equal to mx plus c last time, which is one equation. Now we're going to use y minus y1 is equal to gradient x minus x1. So we're going to be using another formula this time. So when we substitute, what do we get? Right? And of course, we are going to simplify. We expanded the bracket. The bracket that we have here, we expanded it. That is what we got. And that's our final answer. Y is equal to negative 2x plus 14. So let us move on to the other one. Use the 2 points along with the equation y is equal to mx plus c to form a pair of simultaneous equations in which m and c are unknowns. The ordinates in each point will take the place of the x and y in the general equation. So we're going to use y is equal to mx plus c. Right. So we're going to use this point now. So what is the value of y here? 2. What is the value of m? We do not know. What's the value of x? 1. And what is the value of c? We do not know. So we're going to have 2 is equal to m multiplied by x. So we have 1 for the, we do not know the gradient, but the x is 1. So 2 is equal to m plus c, and that is what we'll have. So the point is this. So do not forget the y value is 2. It will go right there. What about the gradient? We do not know. What about the x? The x value is 1. So let's see what we have. Y is equal to mx plus c. We are going to change that. And what do we get? Use 2 is equal to m times 1 plus c. So the first equation is m plus c is equal to 2. Alright? So 2 is equal to 1 time m is m plus c. So 2 is equal to m plus c. But in order that the unknowns, as in typical simultaneous equations, the unknowns are on the left-hand side and the knowns are on the right-hand side. So we're going to put the unknowns on the left-hand side in this case also. So that is why we have m plus c is equal to 2. So that is our first equation. Now, we're going to do the same thing with the other one. Y is equal to mx plus c. What is x? Is 3. And what is y? 1. So 1 is equal to 3x plus c. That's what we're going to have. 1 is equal to 3x plus c. So now we have 1 is equal to m multiplied by 3, which is 3m and plus c. So 3m plus c is equal to 1. Of course, keeping the unknowns on the left-hand side, like typical simultaneous equations. Now, if you remember how to solve simultaneous equations, we do well. If not, we'll have to revise that. We are going to use the elimination method because we can see it working out very quickly. If we have plus c here and plus c, so we know that these are equal. Because these are equal, we immediately subtract the equations. So we're going to say equation 2 minus equation 1. So we're going to say 3m minus m is 2m, and c minus c is gone. Then we say 1 minus 2 is negative 1. So we know what the gradient is equal to. The gradient is equal to negative a half. So we have found the gradient, so we need to determine the value of the other unknown. So we are going to substitute that gradient that we have as negative 1 over 2 into the equation. And we are going to choose, of course, the simplest equation, which is equation 1. So equation 1 is m plus c is equal to 2. So the m is negative a half, so let us put negative a half where m is. So negative a half plus c is equal to 2. So c is equal to, this is going to go over, become a positive a half. C is equal to positive 2.5. And that can be written as 5 over 2. So the equation in the end is y is equal to mx plus c. What is m? Negative a half. What is c? 5 over 2. So we're going to have y is equal to negative a half x plus 5 over 2. Good. And that's all there is to it. Notice that in this approach, the gradient is not found first. A pair of simultaneous equations are developed, finding the values of m and c simultaneously. Now we are going to be looking at parallel and perpendicular lines. Because parallel lines, no problem, let us go through the one that is a little bit more troublesome. So we have, if two lines are perpendicular, then the product of their gradients is equal to 1. So let the known gradient be m and the unknown gradient be n. If they represent perpendicular lines, multiplying them will give negative 1. So mn is equal to negative 1. So that is the rule. If lines are perpendicular, multiply the gradients and the answer is negative 1. So making n the unknown, the subject of the formula, what is what we'll get? Right. So m is multiplied by n, so it is going to be divided on the other side. So m is equal to negative 1 over m. Therefore, if we have the gradient m of a line and we need to determine the gradient n of a line perpendicular to it, this can be done by reciprocating m and negating the result. So we're going to reciprocate m and then we negate the result. And that is how you find the gradient of a line that is perpendicular to one of known gradient. Be aware that negating a positive number gives a negative answer, and negating a negative 1 gives a positive answer. So if you're going to negate a negative number, the answer is going to be positive. And of course, as usual, if you expect to negate a negative number, you expect that the answer is going to be negative. So now we have some gradients. So these are the gradients of some lines, and we are going to determine the gradient of a line perpendicular to each one. But first, let us look at m is equal to 9 over 2, and n is unknown. So mn is equal to negative 1. So 9 over 2 times n is equal to negative 1. So by transposing, we are dividing by 2, so we're going to multiply by 2 on this side. We are multiplying by 9, we are going to divide by 9 on this side. So we have n is equal to 2 over 9. So we have done our reciprocal, and of course we have the negative here. So whereas m is 9 over 2, n is equal to negative 2 over 9. So in the second case, we may use m is equal to negative 7, and n is unknown. So mn is equal to negative 1, just showing you how to work it out. So negative 7 times n is negative 1. So all we need to do is what? Transpose, and we have n is equal to negative 1 over negative 7, and of course, negative divided by negative is positive. So by reciprocating and negating, the other perpendiculars may be written down. So instead of going through the process, we are going to negate and reciprocate, and we'll get the answer for the others. By reciprocating and negating, the other perpendiculars may be written down, so let us do that. 1. The reciprocal of 1 is 1. If we negate it, we're going to get negative 1. For 4, the reciprocal of 4 is 1 over 4, and if we negate that, we are going to get negative 1 over 4. The reciprocal of 1 over 5 is 5 over 1, which is 5. So if we negate that, we're going to get negative 5. For the other one, if we reciprocate this, we are going to get a negative 7 over 3. And if we negate that negative 7 over 3, we are going to get a positive 7 over 3. Or we may just say, just change the sign. So we may say, change the sign after you have reciprocated, so it's going to be 7 over 3. That's what we have. This one, change the sign and invert. So the 2 will go to the top and the sign will be changed to positive. There you go. And finally, the reciprocal of minus 4 is minus a quarter. Change the sign, the answer is positive a quarter, and we have it right there. If we have the gradient of a line, we know how to determine the gradient of one perpendicular to it. Now, if two lines are parallel, they must slope the same way. Their gradient must therefore be equal. No calculation is required in this case. So if they slope the same way, they are parallel and their gradients are equal. So we have 3 problems. As a matter of fact, it's a single problem in 3 parts. So given the 2 points, and we have them right there, determine the equation of a line that passes through them. Then we are going to determine the equation of a line that passes through the point that we have there, negative 2, 4, and is parallel to the one that we had above. Then finally, we are going to determine the equation of a line that passes through 1, negative 3, and is perpendicular to the one that is in B above. So let's begin our process. This time, we are using y is equal to mx plus c, the simultaneous equation. Well, we are just opting to use it because it was not used quite often. It was only used once. So we are just taking the opportunity to use it here again. Not only that, we are going to use the 3 methods. So we are going to start off with this one. How do we get that? Y is equal to mx plus c. In the first case we have here, what is y? Y is negative 5. What is m? M is an unknown. What is x? X is 3. And c is unknown. So the y and the x are known. The x is the one that is going to be accompanying m. Don't forget that y is equal to mx plus c. So m, which is the gradient, is going to be accompanied by the value of x. Right? And we may take a look at how the equations were developed in the first case, and that will help us to understand how we arrive at these 2 equations. But we are using the y is equal to mx plus c, and we are substituting these values for the x values into a pair of simultaneous equations that has the unknowns m and c. Of course, as usual, the c's here are equal, so we can subtract. So let us subtract. We're going to say equation 2 minus equation 1. 7m minus 3m is 4m. The c's are gone. And 3 minus negative 5 is 8. So the gradient is 2. And of course, we are going to substitute that into the simpler equation. We are saying that equation 1 is simpler. So we're going to have 3m plus what is 3m plus c is equal to negative 5. So 3m plus c is equal to negative 5. So what is m? M is equal to 2. And we have just determined that. So let us put 2 there. And of course, c can be easily determined by transposing this. So what do we get for c? C is equal to negative 11. When this, what we have, is equal to 6 is taken to the other side, 5 minus 6, negative 5 minus 6 is equal to negative 11. So the line, equation of a line we are using, y is equal to mx plus c. So what do we have? We have y is equal to m. What is m? 2. So mx, what is c? Negative 11. And that's all there is to it. We have a 3-part question, and we are going to use the 3 methods to solve it. The pair of simultaneous equations are derived by using y is equal to mx plus c and transposing the result. The value of x accompanies the gradient m, and y is on the other side of the equation. This is always a nice system to solve because the coefficients of c are equal to 1 and may be eliminated immediately. The line in B we should have there is parallel to the one in A and must therefore have the same gradient. We have it up here that the line here is parallel to the one in A. So we know the gradient of the line in A is 2. So the line in B must also have gradient equal to 2. And we are going to use y minus y1 is equal to gradient x minus x1. Of course, this is our points. This is our point, and we have here the x ordinate is negative 2, that will go here, and the y ordinate is 4, that will go there. And of course, the gradient is 2 because it has to have the same gradient as the one in A because they are parallel. So we're going to substitute, and of course, we know where the values of m, x, and y will go. That is simplified, and what do we get? Y minus 4 is equal to 2, and then 2 into x plus 2, and we are going to expand. Notice that we are saying 2x goes there, 2 times 2 is 4, and we are transposing this negative 4 from the left-hand side at the same time, so we have another plus 4 right here. So y is equal to 2x plus 8. The gradient of the previous line is 2. Find the gradient of a line perpendicular to it needs no introduction. I hope that it needs no rehearsal. The new gradient is negative 1/2. Reciprocate and negate. Reciprocate and negate 2 will get negative 1/2. So we're going to use y is equal to mx plus c in this case, and we're going to substitute the values. Of course, these are our values. Negative 3 is the y value, and 1 is the x value. The gradient is negative 1/2, so let's see what happens. Of course, simplify this. What do we get? Of course, do not forget that when we have a fraction, we are going to try to write the other number, which is a whole number, as a fraction that has the same denominator. This is done by multiplying by the denominator and placing the result over the denominator. So we have 3 here, so we multiply by 2, we get 6, and we put that over 2. So we have it right there, 6 over 2. As a matter of fact, negative 6 over 2, but we are sure that 2 into 6 is 3, so it is equal to negative 3. However, it is easier to add when the denominators, or subtract when the denominators are the same. So we are going to have negative 5 over 2 is equal to c. So the general form we are going to use y is equal to mx plus c. So y is equal to what is m? Right there, negative a half. And what is c? Right there, negative 5 over 2. So y is equal to negative a half x minus 5 over 2. And that's our solution. Now we are going to take a look at some special lines. What is consistent about the x-axis? Put some points on it and write down their coordinates. This might help. So we have some points there on the x-axis. So we write down the coordinates. What are the coordinates? P is 2, 0, Q, 5, 0, R, negative 1, 0, and S, negative 4, 0. The consistency is clear. The y-ordinate is always equal to 0, and that is the equation of the line. Y is equal to 0. That's the equation of the x-axis. Y is equal to 0. Determining the equation of the y-axis is analogous to determining the equation of the x-axis. Its equation is x is equal to 0. Continuing with our special lines, let us place some points on our first line and examine the coordinates for consistency. So that is our first line. What can be noticed about the coordinates of the points? The coordinates are P, 3, 3, Q, 2, 2, R, negative 4, and S, negative 1, negative 1. Notice that the x and y values in each pair of coordinates are equal. No surprise. The equation of a line is therefore y is equal to x. Let us place the points on the other line and write down new coordinates. So we're going to put those points on the other line. Put some points over there. Good. Write down the coordinates. The new coordinates are P is equal to negative 3, 3. Q is equal to negative 2, 2. R is 4, negative 4. And S is 1, negative 1. Notice that whatever the x value is, the y is the negative of it, or vice versa. We may write the equation of the line as x is equal to negative y, but it is more appropriate to write y is equal to negative x. So that line, y is equal to negative x. Do not forget how the line slopes and generally the points that the lines are expected to pass through. These lines will come up, no doubt, somewhere again when we are working in our CSEC mathematics resources. Now we are going to be looking at parallel lines. We know already that parallel lines have the same gradient. And of course, in an equation of a straight line, the gradient is required and the y-intercept is also given. The equation of one line is written. Write down the equation of the other lines that are parallel to it. The lines are parallel. They all have the same gradient. In the equation, y is equal to mx plus c. M is the gradient, which is also the x coefficient. The other equations will have the same gradient. X coefficients, right. The other number c tells us where the line crosses the y-axis. The only difference in the equations will be the value of c as indicated on your y-axis in the diagram. So the only difference is going to be this. So the first one we have y is equal to 2x minus 2. That one must be y is equal to 2x plus 3. Why? Because the gradient is the same and the gradient is the x coefficient. Now we have this 3 that was discussed early in the lesson, which is the y-intercept. And we can pick up that y-intercept right there because it crosses the y-axis where y is equal to 3. So we just put the 3 right there. And we do the same for the other one. Same gradient, it crosses the y-axis at 1, 2x plus 1. Same gradient, it crosses the y-axis at negative 4, y is equal to 2x minus 4. Here we have another line. The equation of one line is written, of course, and we are going to write down the equation of the other lines that are parallel to it. As usual, the lines are parallel. They have the same gradient. The only thing that will be different in the equation is the value of c, and this is identically equal to the value where the line crosses the y-axis. In one case, the value is 0. It is not necessary to put positive 0 in an equation, and the line is expressed without a visible y-intercept. So they are parallel, so they have the same gradient. They therefore have the same x coefficient. And of course, what is going to be different? The y-intercept, which is right there. And the same thing is done right there. Same x coefficient, because this is the gradient, so same gradient, and the intercept is 3. And this one passes through the origin where the value of y is equal to 0, so it should have been negative 2 over 5x plus 0, but we do not need to have that 0 included. Sometimes students cannot recall the difference between a positive slope and a negative slope. The one that goes in the direction of the uplifted right hand is a positive slope. There. Your right hand is going sloping like that, so any line that goes up in that direction has a positive slope. The one that goes in the direction of the uplifted left hand is a negative slope, like that. So no problem determining the sign, whether it is positive or negative, of the gradient of a straight line. This is very, very beneficial when students need to determine the gradient of a line of which a graphical representation is given. In the event that some mistake, especially with the sign of the answer, it can be easily detected.